Okay, so here are some example problems on solving and applying quadratic equations. So basically how we're going to choose our different methods or what strategy we're going to use to solve for this quadratic equation. So now we know three different methods, basic factoring, and then we use the zero product property. So the zero product property allows us to solve for the x-intercepts once we have them separated into two factors. We also know how to complete the square and to solve for x. And then now we also know how to use the quadratic formula to solve for x. Okay, so here, first we're going to decide which strategy to use, and then we will solve the equation. All right, so let's go ahead and look here. Remember, I will be moving rather quickly in a video because you can pause and rewind. So pause whenever you need to. I always like to try the first strategy if it's in standard form like here, and the numbers look manageable. So I'm going to see if it is factorable. It's not always factorable, right? They're not always going to work perfect, but this one looks pretty good. So all the numbers that multiply to 27, I have 1 times 27 and 3 times 9. 3 plus 9 is 12x. So I know that my two factors are 3x and 9x. And this one works. So I'm going to go ahead and create an area model. And I'll go ahead and color code just to remind you that I got this 12x because that's the bx term and it goes at the bottom after I multiply the a and c terms. So the x squared and the 27 always have to go diagonal from each other. Okay, so we have x squared, 27, and then we have 3x and 9x here. Okay, and then here we have the GCF between these two is x. Remember, pause this and try to do this on your own first, okay? Try to keep that in mind, just so that you're not just watching and maybe zoning out while I'm doing the problems. I want you to really try it on your own. And my videos are really to help guide you if you get stuck or to check your work. Okay, so now we can split them up. X plus 9 equals 0. X plus 3 equals 0. And this is the zero product property, what we're doing here. Up here was just factoring, like with the basic x and the area model. Okay, now we're using the zero product property to actually solve for x. So here, we have to subtract 9 from both sides. So we're going to get x equals negative 9. Here we have to subtract 3 from both sides, so we will get x equals negative 3. So those are our answers. So our x-intercepts are negative 9, 0 and negative 3, 0. Okay? So let's move on to the next one. This one's kind of a throwback. If you notice here, these two are both perfect squares, so this is what we call a difference of squares. And this here we have a shortcut for. So whenever we have a difference of squares, you can definitely look it up to see more notes on it. We did this back last semester whenever we first started learning about quadratics. So here, difference of squares will look like this. Okay? So what we do is we take the square root of the first term, and that goes in each of the first spots there. So the square root of 4x squared is just 2x, because 2x times 2x is 4x squared. And then we take the square root of this term and put that in each of these places here. Square root of 121 is 11. Okay, so then this is equal to 0. So now what we can do is split it and use the zero product property to find my x-intercept. So it's all nice and factored now. So now I just have to solve for x. So here I'm going to subtract 11 from both sides. I get 2x equals negative 11. Divide both sides by 2. Get x equals negative 5.5. So that's one of my x's. Add 11 to both sides here. 2x equals 11. Forgot to switch up my colors. Divide both sides by 2. X equals positive 5.5. So your x-intercepts are negative 5.5 comma 0 and positive 5.5 comma 0. Okay, so those are your x-intercepts. Now if you wanted to check this and see like, okay, how does 2x plus 11 times 2x minus 11 equal 4x squared minus 121? This is how. You can always multiply your factors back out into an area model and see what you get. Okay, so here we're going to have 2x times 2x is 4x squared. 11 times 2x is 22x. Negative 11 times 22x is negative 22x. Negative 11 times positive 11 is negative 121. So here we have 4x squared plus 22x minus 22x minus 121. So these two here cancel out. 22x minus 22x is just 0. So we are just left with 4x squared minus 121, which is what we started with as well. So that's why the difference of squares works in this case. Okay, so that's that one. Again, please pause throughout the video. The next one is way down here. This one's already factored. This is easy, nice and smooth. Zero product property. You don't have to factor anything. You just have to split them up because they're already in their factored form. So we just set each one equal to 0, and now we can just solve for x. Okay. So here, my first step, I'm going to subtract 4 from both sides. And I have 3x equals negative 4. So I'm going to divide both sides by 3. And this will give us a repeating decimal. So negative 4/3. It's about the same as negative 1.33. It'd be 1.3 repeating forever, but if you wanted to see the decimal to plot it a little bit easier on a graph, this is roughly the decimal, 1.3. Here I'm going to add 1 to both sides. So we have 2x equals 1. So now if I divide both sides by 2, I'm going to have x equals 0.5. So my x-intercepts are about negative 1.33 comma 0 and 0.5 comma 0. Okay, so pause the video if you did not get all that down. I'm moving on. This one's a mess. We need to rewrite it into standard form before we can do anything. Like this. So what I need to do is move these terms over. So I'm going to add this 4, add the 4, subtract 8x, subtract 8x. I cannot combine these two, but I'm just writing it there because I don't really have anywhere else to write it. So I'm doing this all in one step. So I have x squared minus 8x. The 12 and the 4 can be combined, so it's plus 16 equals 0. Okay, so the first thing again that I like to do is see if these are factorable, just with the basic factoring. So I have 16x squared, and then the bottom is going to be this negative 8x here. Okay. So for 16, I know 1 times 16 is 16, 2 times 8, and 4 times 4. 4 plus 4 is 8, and then if we change these all to negatives, right, because negative times negative is a positive, negative 4x plus negative 4x is negative 8x. So that works very nicely. And negative 4x times negative 4x is positive 16. Okay, so here if we go and do the area model, we have, I'll go and color code again just in case it helps you. The A term and the C term go across from each other. And then my factors also go across from each other diagonally. So I have x squared, 16, and then in here negative 4x and negative 4x. Okay, so this is going to be, please pause and try it out on your own first. But here I have x minus 4 times x minus 4. So now I have x minus 4 times x minus 4 equals 0. You could split that. You'll get 4 for each of the answers. You could also write x minus 4 squared equals 0, because that's what these are. Something times itself is just that something squared. So here I can take the square root of both sides to cancel out the squared. I have x minus 4. Square root of 0 is just 0, so no plus or minus there. So now I can add 4 to both sides. And we end up with x equals 4. So my x-intercept here is 4, 0. Okay, so again, make sure you pause and get all this down and understand what I just did. Oh, these are ugly numbers here. Look at this. Okay, so we have to make it in standard form, which means ax squared plus bx plus c. You guys see this 60x here needs to be moved over to go in its bx term spot. So this is going to be 36x squared minus 60x plus 25 equals 0. Now you definitely might be able to factor this, but these are huge numbers, okay? And also, since this is not a 1 here in front of the x squared, we cannot complete the square. So in my opinion, I just want to use the quadratic formula without trying to give myself a headache of figuring out if it's factorable or not. I'm just going to use this formula and simplify my way through. So first I need to identify A, B, and C. So I'm going to color code. I'm going to say my A, 36. Okay. Here I have A. Now my B is going to be this negative 60. Okay, that's where the BX goes. We'll plug that in here and here. And then my C is positive 25. So this is where it gets plugged in. Okay. So I'm going to write those out. So 36, negative 60, positive 25. So I have x equals negative. Always put whatever you're plugging in into parentheses here. Negative 60 is my B times 36 times 25. All over 2 times A, so 2 times 36. These are huge numbers, so you might definitely need a calculator for some of them, and that's okay. All right. So just in case it helps you, I'm just going to highlight like where my numbers were, just so you can see the relationship there, where I plugged in numbers and what they were from the get-go. So here, negative times a negative 60, just a positive 60. Negative 60 squared is negative 60 times negative 60. We're going to get 3,600. Okay, and then this one here I need to use a calculator for. So we have, or actually not really, 4 times 25 is 100. 100 times 36 is just 3,600. So this will be 3,600 minus 3,600. And look at that. Look at how nicely that worked out. Okay, 2 times 36 is 72. So here we can simplify the inside. We're going to get 60 plus or minus square root. 3,600 minus 3,600 is 0. All over 72. So this is just 60 over 72, because plus or minus 0, that's just 0, right? So we don't even need that. So x equals 60 divided by 72. If we were to divide that, let's see what we get. .83 repeating, okay? So it's about equal to 0.833. And then this 3 would go on forever, but on a graph, you know, we're not going to say, oh, it's repeating, because it's not really possible to graph a repeating decimal. So, but this is your x-intercept. Okay, that's approximately our x-intercept there. So this was the quadratic formula. Just a lot of simplifying and whatnot. Okay, let's see this one here. This one looks kind of messy too. So it might be another quadratic formula one. All right, so this is our last one here. So again, I need it to be an ax squared plus bx plus c equals 0 form. So I need to subtract the 2x from both sides. And I'll do these in 2 separate steps in case it confused you earlier how I did them in the same step. Becomes negative 32x equals 45. Now I need to subtract 45 from both sides as well. So I have 20x squared minus 32x minus 45 equals 0. Okay, so now it is in ax squared plus bx plus c form. So if we want to color code, these are my a's. I'll write it out there. My b, and then my c. Okay, I'm just going to go steal this formula over here so I don't have to rewrite all that again. Okay, so here I'm going to, let me go and paste that, there we go. So this is the formula I need to use. Okay, my A is 20, my B is negative 32, and my C is negative 45. Okay, so here I have x equals negative 32, negative 32 squared minus 4 times 20 times negative 45. Oops, I ran out of paper. All over 2 times 20. Okay, let me go and move this over here. There we go. All right, so now we have to start simplifying. So we have x equals this negative times negative 32 is just positive 32. 32 squared, I'll just do it here. $1,024. And then I have, so it'd be 4 times 20 times 45. $2,000. Oh wait, was it 25 or, gosh, I always forget. 45, sorry about that. It's not 25, 45. 3,600, okay? So going back here, and since it was a negative 4 times 20 times negative 45, this is going to be plus 3,600. It's a positive. 2 times 20 is 40. So now here, we have 32 plus or minus. If we add those two together, we get 4,624. Okay, so let's see if that is a perfect square root. It is 68. Okay, so these are really pretty because they're working out nicely. No decimals. So this is 68. So we have x equals 32 plus or minus 68 all over 40. Because the square root of 4,624 is 68. So now I need to split. Again, I'm splitting the plus or minus. So I have x equals 32 plus 68 all over 40, and x equals 32 minus 68 all over 40. Now you can definitely use a calculator for this. Okay, we're going to get some exact answers here. And again, whenever I split it, I split this plus minus. So 32 plus 68, then we got to add parentheses here to divide it all by 40. So that one is 2.5. Let's do, I always forget my parentheses, 32 minus 68, all divided by 40. So let me make sure that those were the right 32, 68, 40. Yeah, okay, so 2.5 and negative 0.9. Negative 0.9. These are your answers. So your x-intercepts are 2.5 comma 0 and negative 0.9 comma 0. Okay. So I believe that is it. Let me just, yep, okay, good. I wrote down the right answer. Yes, I believe that is the last one. Yep. So hopefully this helped you just review strategies. We did not complete the square on any of these because we just didn't need to. So these worked out pretty nicely. Definitely review all three strategies no matter what though. They're all very important.